Hello everyone, now we are going to learn about the complement. So I'm giving you the compliment that you are studying very well. So this is the side of my complement. So what is the mathematical complement? Like let's say we have a number 7. So what is going to be its complement? To find the complement in decimal number system, we subtract with 10. So 10 minus 7 is 3. So this is going to be the complement. Like let's say I take 81. So the complement for 81 is 100 minus 81, which will going to be 20. No, 19, right? Yes, of course, 19. So with these two examples, I assume that you have got the idea of what the complement actually means. We reach to the nearest point of the decimal where the thing starts repeating. Like after 10, we starts repeating the thing 11, 12, 13, and then we reach 20, and then we reach 30, 40, and all the way towards 100. After 100 we start repeating. What repeating I mean with 100, 101. So this is the repeating I meant with, like in this case 0, 1, 2, and all the way to 19, right? Then again 0. So 10, 100, 1000 are the complements for the number that are closest to them. Okay, I hope you have got the idea of the complement. So let's do one or two more questions to understand what is the complement in the decimal form. Let's take an example, right? Like 742. So if I tell you to find the complement of this number, how we are going to write it at? We first check that this is a 3-digit number, so we need a 4-digit number that will be going to be greater. Like in this case we need 1000, and then we subtract 1000 with 742. So the basic logic of and the concept of the complement is zeros and one. Now you are able to see that even in the concept of the decimal we use zeros and ones, so that's why it is related to the binary. Absolutely. So now on solving we are going to get, of course 0 cannot subtract 2, so we are going to take 10. So this will going to be 8, this will going to be 9, and this will going to be mhm, 9 minus 4 is 5, right? Okay, we all know that obviously. 9 minus 7 is 2. 258. So 258 is the complement of 742. Sometimes in mathematics and in the general calculation, we also require the complement of r to the power minus 1, or in simple word 999. So 999. That's what I meant with r minus 1's complement. So I can say the tens are r's complement. Hmm. Now you get the point. So why we take this number? Because this is 3 digits greatest number. 3 digits greatest number. And if you look closely, so in this case 1000 is the smallest 4-digit number. This is smallest 4-digit number. So we can take it in two possible ways. First, by comparing from the smallest. Second, from the biggest. In the biggest one, we have like let's say we need to find 742's complement again, but now this time we need r minus 1 complement, or 999 we wish to use. So 999 minus 742. So what will going to be our answer? Well, our answer will going to be 257. So this complement is on the basis of 999. So number of digits are same here, just the greatest number. Hmm. Okay, we have understood all these things, but I am also pondering that why you are teaching me these things. Why? Why? Yes, I know you are curious at why we are learning all these things. This seems like maths, not digital electronics, so the question is quite obvious. I can understand that. But the fact is, binary world is also using the complement, and this complement concept is going to help us in the higher studies when we do in the binary calculations. So nothing goes wasted, like, right? Okay, so let's learn a tricky part for the binary complement. Like, now I want the complement of, let's say, the number is, what we take. Let me take an example. Like, let's take, 8. So we need to find the complement of 8. Well, so what's new in that? In the binary form. Yeah, in the binary form. So how we are going to do that? Hmm. Now you can ponder that how we are going to solve the binary world. Binary world. Okay. Okay. So how we are going to solve this binary world? Well, that's not that difficult. 10 minus 2, oh sorry, 10 minus 8 is 2, right? That's it. Now convert that 2 into binary form. So what is the binary form of 2? 0, 1, 0. Well, you do not need to write the 0. You can just simply write 1, 0 and this 2. That's it. Hmm, that is easy. So let's do something complicated either. What is the binary form of 101's complement? Now you are talking. Find its complement. So, how we are going to find its complement? Find its complement. Well, we are going to use our old classic trick, which is convert this number into decimal form first. Yes, this is going to be our ultimate. So 2 to the power 0 plus 2 to the power 2. Well, I have not written this one because 0. So this is just nothing but 5, the number 5 in decimal. So the complement will going to be 10 minus 5, which is obviously the 5. So what is our answer? 101's complement is 101. Yes, exactly. So this is the way we convert the complement. But there is also an alternate way. Like in the binary, we have its own things. So let's take an example here. 0, 0, 1, 1, and let's make it 8 digits or 8 bits if you like it that way. 1 1 0 0. I just flipped this number, that's it. Okay, now we need to find its complement without converting into decimal form. Obviously we are not going to convert decimal form for this much big number. So how we are going to find it directly? Well, I am going to write something. Try to figure out the pattern. 1 1, 0 0 0 1 0 0. That's it. Well, I should write it here. Let's rub this one. Well, did you got that? Did you get the pattern? Well, it's very easy. Let me just tell you that this shortcut allows a person to convert a number to its two's complement without forming one's complement. One's complement, or you can say tens complement, like 10 to the power of 1, or 10 to the power 2, or 10 to the power 3, that thing, like, okay? So, how we did that? Let me tell you. Until the first one is reached, Then copy that one and take the complement of all remaining bits. That was exactly what I did. Okay, let me make it even simpler for you. So 0, just write 0. Again 0, just write 0. Now we hit the first one. So write 1, and after that start switching the numbers. Like in place of 1, switch it and make it 0. Okay, let me change the color so that you can see the things quite clearly. Okay, this one. Convert it. Now 1 gets converted into 0, and this one get converted into 0. This 0 get converted into 1, and this 0 is also going to get converted into 1. Hmm, that's easy, right? That's funny. Let's practice one more. If you have understood this, try this one by yourself. 1, 0, 1, 0, 0, 1, 1, 0. No matter how much big or small number I write, it will going to remain the same. So, what will going to be our answer? I'm waiting. So, in place of 0, we are going to write 0. Okay, you can pause the video and try that for yourself and then come back and check. Okay, now we hit the first one here. So, I'm going to write 1. And then here's 1. So, I'm going to write 0. Then double 0. So, I'm going to write double 1. Then 1 in place I am going to write 0, then 0 I'm going to write 1, and then 1 I'm going to write 0. So this is the complement. So now you might be getting interested that yes, there is a way we can beat the machines. Machine cannot do it that fast. We can do it. Congratulations, buddy. You are smarter than the machines, of course. So we have learned the complement, and this is all for the complement. So there are just two properties of the complement or two's complement. Let's see that very quickly. Two's complement is having two things. First can be the positive number, and second can be negative number. Well, we have just dealt with the positive. There is also a negative number. Well, in the positive one, it is just a simple binary form. Simple binary, as we have just done, we have done the positive form already. In the negative form, we have to find a number in such a way that the answer becomes 0. Yes, like if you are given plus 5, you have to look for the minus 5, and that will going to form 0. Or if you are given 742, you have to look for the exact same number just with the negative sign, and that will again going to get 0. So this is going to be the negative one. That's why I have not took you in the practice of negative numbers, because we already know that all. Okay, so that's it for the complement, and we're going to see the next exciting thing in the next one. So stay tuned and God bless.